Hello friends, I am coming with question number 20 of Pathfinder Newton laws of motion. What is the wording of this question? The question is saying while a block is sliding on a horizontal floor, a constant horizontal force is applied on it opposite to its direction of motion. Which of the following can be correct velocity time graph for the ensuring the motion of the block? Okay, so what is the situation is given? One block is moving. Let's say this is a surface, and I consider this surface is a rough surface. So if it is the rough surface, then one block is placed here. There's a block, and this block is moving with the speed of v in this direction. So we apply the one force, constant force in the opposite direction of the block, that is called F. And because the motion of the block is here, the rough surface is also apply one of the forces in this direction, that is called kinetic friction. So acceleration, the retardation on block is A is equal to F plus small fk by m. This retardation, because of this retardation, the velocity is continuously decreases. And tell you the fk is also constant. So you can say that the velocity is decreases linearly. My dear friend, velocity is decreases linearly. So if you draw the curve, then I want to draw the velocity versus time curve. And this curve is continuously decreases like this. But because when the block will become at rest, what is happening? This block is at rest, and this case V becomes 0. One force is still present. This force is F is acting in this direction. So because of this forces, the block is start to feel the acceleration in this direction. But be remember, my dear friends, if this is the rough surface, then rough surface has a friction coefficient mu s. So if F is greater than mu s mg, then this block is start sliding. Then block start sliding in the direction of capital F. Okay. So what situation will happen? I want to clearly know. So again I want to draw the curve, velocity versus time. So this velocity is continuously first of all decreases. Once it is decreases, the acceleration rate is F plus mu k mg by m. But again the velocity is then the acceleration in this case is what? F minus mu k mg by m. So you can say that the slope is decreases. So the curve is like this. Okay. So remember, if the force is acting more than the limiting friction force, the curve is designing in such a way the velocity is after at a particular time the velocity is going in the same direction of force. But if the force is less than mu s mg, so after reaches here, the block become at rest. There is no sliding. There is no motion. So in my point of view, you can say that if force is varying in such a way, and there is a two conditions, one is F is greater than mu s mg, other one is F is less than mu mg. So if F is greater than mu mg, then of course the sliding is still going on, and after a particular instant, at this instant the velocity is changes and it is going in the direction of force. But if F is less than mu s mg, at this instant the block become at rest, and always is at rest. So the correct answers are, in my point of view, the correct answers are A and D. I tell you, some students have a confusion, why not B? I tell you, there is the time lagging. So there is nothing, it is not possible. Okay, there is no time lag, there is no time interval to exist between F minus mu s mg, and then after some time, immediately the particle will start a motion. So thank you so much for watching this video. If you have any comments, you can write in my comment box. Thank you.